Hello everyone, I'm Litao. Today I will be presenting visualizing examples of deep neural networks at scale on behalf of my co-authors, Elena, Glassman, and Tianyi Zhang from Harvard University. In recent years, deep learning models have gained a lot of attention. In our formative study, we found that most developers use online search to find example models. However, they often had difficult time choosing appropriate model structures and hyperparameter values. In this work, we present ExampleNet, a novel interactive visualization interface for exploring common and uncommon design choices in a large collection of open-source deep learning projects. Many neural network visualization tools have been proposed to support different activities in neural network development, such as TensorBoard, TensorFlow Playground, LSTMVs, etc. ExampleNet differs from these visualization tools in three perspectives. First, unlike prior visualization tools, which only represent a single model at a time, our tool represents nearly 100 models. Second, prior visualization tools mainly focus on debugging or training processes. Our tool supports model design phase. Third, our tool allows users to compare and contrast multiple models and their design choices at the same time. From a semi-structured interview with 10 deep learning beginners we conduct, we distill 10 information needs they intended to discover from online search when building neural networks. We summarize 3 design principles based on the information needs. First, we need to help users understand the relevance of the online examples to their own tasks. Second, we need to help users distill high-level design decisions. Third, we need to help users understand the commonalities and variations of design choices. Now, I will briefly introduce our interface. Suppose Alex is a beginner in deep learning. He wants us to implement a deep learning model for image classification. Instead of using online search, Alex chooses ExampleNet. He finds and selects image classification on the multifaceted browser. He then looks at the distribution of layer types. Alex noticed that the majority of projects use convolution layers, but he is still not entirely sure how and where to use them. To figure it out, Alex turns to the overview diagram of model structures. He finds that most projects place convolution, max pooling, and RARU layers at the beginnings of the neural networks. He also clicks the alignment view and notices that many networks contains convolution RARU max pooling pattern. After getting an understanding of model structures, Alex explores the distribution of hyperparameters to find out what common and uncommon hyperparameters are used by other developers. He notices some projects choose the learning rate at 0.001, which gives him an appropriate learning rate start point. We develop a semi-automated data curation process that extracts model characteristics from GitHub projects. Through the static analysis, our analyzer extracts the layer sequences, hyperparameter values, and the parameter values from the source code. We manually extract the metadata, such as the dataset names, tasks, model types from the README files. We conduct a within-subject study with 16 participants to evaluate ExampleNet. We select 2 common deep learning tasks, image classification and text classification. For each task, participants were asked to design the neural network structures and report the hyperparameters, either using ExampleNet or online search. The study result shows that, first, when using ExampleNet, participants inspect 3 times as many GitHub examples than when using online search. Second, ExampleNet brings programmers more awareness of various design choices, such as different types of layers and hyperparameter types. We also accessed the model they designed. We found that using ExampleNet significantly reduced participants' mistakes in neural network design and hyperparameter design. Participants also felt more confident about the neural network they designed with ExampleNet and rated it as more helpful than online search when designing neural networks. To sum it all up, our work has 3 main contributions. First, a formative study that identifies real needs of deep learning learners. Second, a novel interactive visualization of a large collection of deep learning models. Third, a within-subject user study that demonstrates the usefulness of ExampleNet to deep learning programmers when using their own neural networks.